Now when we add heat to a substance, it can cause its temperature to change, but the other thing it can do is cause it to change state. So for example, we could cause ice to melt. We have to add heat to cause the ice to become liquid water. We also need to add heat to cause the water to boil, so to cause the water to turn from a liquid to a gas, which is what happens when our kettle starts to boil. So the amount of heat we have to add to cause a substance to change state is called the latent heat. We can have the latent heat of vaporization, which is the amount of heat we need to put in to cause it to change from a liquid to a gas, or we can have the latent heat of fusion, which is the amount of heat we need to put in to cause it to change from a solid to a liquid. The equation relating the amount of heat we need to put in to the mass of the substance is given by heat is equal to the mass of the substance times L, which is the latent heat, either of vaporization or fusion, depending on what process we're doing. Now there's no change in temperature term there because as this heat is being transferred, the substance stays at a constant temperature. We will look at this in a bit more detail very shortly, but for now, let's just have a look at an example of how we can make use of that latent heat equation.
Okay, so we're asked, calculate the amount of heat that needs to be added to convert a 20-gram ice block from ice to water. How much heat needs to be added to convert 20 grams of liquid water to a gas? And we're told the latent heat of fusion for water is 3.33 times 10 to the 5 joules per kilogram, and the latent heat of vaporization for water is 2.26 times 10 to the 6 joules per kilogram. So to work out the amount of heat that we need to add, we can just use the formula Q is equal to mL. Now, as this is in joules per kilogram, we're going to need our mass in kilograms rather than in grams. So the mass in kilograms is 20 times 10 to the minus 3, which is the same as 20 divided by 1,000. And then we multiply it by the latent heat of fusion, so that's 3.33 times 10 to the 5. So solving this on the calculator, we get 6,660 joules. So we need to add 6,660 joules of energy to melt the ice. Now, this is why you add ice cubes to your drink on a hot day. If you add an ice cube, which would be about 20 grams of ice, then it needs to absorb this much energy from the surrounding drink to melt. And so as it melts, it absorbs that energy from the drink, which lowers the temperature of the drink because the energy is given by Q equals mc delta T, so the temperature of the drink decreases, and that is how you cool your drink. Now, to calculate how much heat we need to add to cause the water to turn into gas, we use Q is equal to mL, but we're now using the latent heat of vaporization. So once again, the mass is 20 times 10 to the minus 3 kilograms, and then we use the 2.26 times 10 to the 6, and solving this, we get 45,200 joules. So that is actually why you have evolved to sweat on a hot day. So on a hot day, you produce this liquid on your skin. The liquid then evaporates, and as it turns into a gas, it absorbs this energy. So if you were to evaporate 1 tablespoon of sweat, it would require approximately this much energy, and so that energy would be lost from you and you would be cooled down. What we're going to consider now is what happens to a kettle filled with ice as we add energy at a constant rate, i.e. a constant power. What you can see here is when the power goes on and the kettle's heated, first of all, the added energy from the power goes into melting the ice. While this happens, the temperature remains at a constant 0 degrees C. When the ice is finished melting, the power added through the electrical power then goes into heating the water and increasing the water's temperature from 0 degrees C to 100 degrees C. When it gets to 100 degrees C, the extra heat energy which is added goes into boiling the water and converting the water into gas.